Hey y'all, in this lesson we are looking at comparing and ordering real numbers. So we want to be able to compare and order rational and irrational numbers, which together make up real numbers. A reminder that an irrational number is a number that basically cannot be written as a fraction. We'll write down our essential question: how can you compare and order rational and irrational numbers? In our first example, we're going to look at approximating an irrational number. In this scenario, Darcy wants to add ribbon that is shown in pink along the diagonal of the rectangular flag she's designing. So the diagonal is the line between the green and the yellow here. Does she have enough ribbon? Well, we see that we're being shown that this diagonal is the square root of 74 feet, and we have 8.5 feet of ribbon. So we need to approximate this number to figure out if 8.5 feet is enough. So let's get started. We are approximating the square root of 74 using perfect squares. First, because 74 lies between the two consecutive perfect squares of 64 and 81, the square root of 74 is located between 8 and 9, because 8 is the square root of 64 and 9 is the square root of 81. So we know between which two numbers this is going to be. But we want to find a better approximation by using decimals. So, because 74 is closer to 81 than it is to 64, the square root of 74 is closer to the square root of 81, or 9. Then we compare. First, we might try 8.5 times 8.5 and get 72.25. We'd notice that this approximation is too low, so we try the next value up, 8.6 times 8.6. We saw this in lesson 3. This is much closer to 74, and so we would approximate that the square root of 74 is about 8.6. The length of the diagonal, this should say the square root of 74, is about 8.6 feet. This means that Darcy does not have enough ribbon, because she has 8.5 feet, but we need 8.6 feet, so she doesn't have enough ribbon. You try comparing the square root of 12. Between which two between which two perfect squares would 12 be? Then, same answer but with a radical, so put a radical over it, and use that to determine what is the square root of those perfect squares to see between which two consecutive whole numbers this is. Try it on your own and then see the answer. In our next example, we are going to compare a square root and a decimal and put them on a number line in order to determine what order they come in. So the first step is looking at the square root of 32. We need to approximate this using perfect squares. So just like in that last example, we say between what two perfect squares is this? Then we take the square roots to determine that the square root of 32 is going to be between 5 and 6. Then we find a better approximation using decimals. We might first try 5.5 because we're looking for something that is more than halfway, and we want to figure out what is the best. So 5.5 times 5.5. And you can see from the slide we would get 30.25, which is too low. So we might try the next one up, 5.6. And you can see from the slide, we get 31.36, still a little bit too low. So we would then do 5.7. And you can see that's 32.49. So that's a little bit too much. So we know that the square root of 32 is somewhere between 5.7 and 5.8, or sorry, 5.6. So this is how you can start to get a closer and closer approximation. Next, we'll approximate our decimal number. We're going to approximate 5.51326 as a rational number by simply rounding to the nearest tenth. So when we round to the tenth, that is the first number past the decimal. We look at the second number to determine if we need to round up or not. The 1 tells us that we're going to stay the same. So when we approximate this, 5.51326 is about or approximately 5.5. We can see that that is lower than the lowest possibility for our square root. So now we can put these in an order. We can draw a number line between 5 and 6, and we can put our points on that number line. So we have 5.5, or that decimal, right at approximately 5.5, and our square root is between 5.6 and 5.7. So we can place those on the number line. That means that our decimal is less than our square root. Let's look at one more example. Comparing and ordering a set of rational and irrational numbers. We're asked to compare and order these numbers. First, we'll use rational approximations to estimate the value of each irrational number. So pi we know is irrational, therefore pi squared is also irrational. But we can approximate it by saying that it is about 3.14 times 3.14, which is equal to 9.8596. 9.5 we can rewrite as a decimal as 9.5. 9.8 we don't need to rewrite. 9.5 repeats. We know that that is 9.55555, on and on. And the square root of 94, we can approximate the same way we have been doing, and we would get 9.7, or about 9.7. Now we can put each of these on a number line. And once they're on the number line, we can quickly see the order that they go in. So we have our smallest is 9.5, or 9.5. Then we have 9.5 repeats. Then the square root of 94, followed by 9.8, and finally pi squared. You try this problem and then watch the video to see if you got it right. Finally, we'll summarize what we just learned. In order to compare rational and irrational numbers, you must first find rational approximations of the irrational numbers. You can approximate irrational numbers by using perfect squares or by rounding. So if it's a square root, you'll use perfect squares. If it's not a square root, then you will round to the 10th or 100th spot to get a good approximation. And one little picture example of putting the square root of 2 on a number line. We know it would be between 1 and 2, and we can approximate it further by finding it would be between 1.4 and 1.5. And you can get as exact as you want, but know that in irrational square roots, you will never find the exact value. Your next steps are to submit your 7.5 notes, complete your Build 7.5, and take your 7.5 mastery check. Good luck.